So I'm going to back up now. Okay, so I'm going to start this. I think it's recording now. Okay. So let me draw. Here is a motion diagram, right? Okay. So I'm going to draw some dots. So let me start it here. It starts here and then does this. Okay, and then that'll be part one. And then part two will be this. And then part three will be this, like that. Okay, so you guys see the three parts there? Part one, positive direction speeding up, right? Part two, positive direction constant speed. Part three, positive direction slowing down. Fair enough? Let me actually draw a position graph just so that we can sort of see how these all relate. So part one would be positive speeding. You know what? Hold on. Would be, let me erase that a little bit. Part one would be positive speeding up. So kind of like an upward curve like that, right? Part two would be positive constant speed, something like that. Part three, positive slowing down, this thing along those lines, right? Okay. Let me extend this. Actually, I can sort of see I'm going to run out of room here. So let me just, okay. All right. Let me add onto this motion diagram a scale. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be like, so like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Fair enough? Okay. So now let me talk about some of the stuff we've been talking about the last couple of days. Like, see this term here? I'm going to kind of look at this in blue. Initial position. So you can see the start position right there. Do you see the first dot is clearly at position 2, right? So you could say this initial position is 2. You could potentially say that, right? And then see the very last dot looks like that position 4. So that'd be 12, right? Notice that with these two, you can also then, so you get a displacement. Because then that'd be the 10, right? Do you get from one to the other? Okay. I'm going to go ahead and add those numbers onto my position graph because so you can kind of see how those numbers would be represented with the position graph. Like this initial position right here would be 2, right there on that scale. And the final position is all the way up here, it looks like there. That's going to be 12, looks like, right? So that's where those two positions would be on the position graph. Fair enough? And then obviously the displacement is just the difference between those two numbers, okay? All right, so here's one thing that may have been, I kind of glossed over a little bit, but now I want to be a lot more very explicit about it. These two positions have very specific times associated with them. So see, like for example, this first position, that represented the time at the very beginning. So we'll call that, that's very specifically time 0, okay? The very beginning of time. So that would be represented here on this graph, like 0, right there on the t-axis, right? Time on a motion diagram now is a little bit, like we didn't really talk about how time is represented in a motion diagram, but it's sort of like the number of dots. So like, for example, let's just say those dots, remember it's like me dropping breadcrumbs? Let's say it's dropping breadcrumbs every second. Drop, drop, drop. So every one of those dots represented 1 second, right? So that you can sort of count the time. Like, so I start at 0, the next dot is 1 second, the next dot is 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6, 7, 8, 9. So can you guys sort of see if I start at 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That last dot happened at 9 seconds. So that time would have been 9 seconds at the end. So what I'm trying to say here is that these two positions right here, and I can add that time right here to the position graph, those two positions also happen at certain very specific times. Okay? In this case, 0 and 9. So when you find this displacement, that is this displacement between those times from 0 to 9. Okay? So there's this. So does this sort of slide kind of, you see where these numbers are coming from? Okay, so I'm going to show you then a little bit about how things, because I can change these numbers right here a little bit. So let me copy this screen. Okay, now I'm going to erase this set of numbers right here. Because I can kind of focus, instead of the entire section graph, I can focus, for example, just on part 2. So I'm just going to focus in on part 2 alone, right? Part 2 alone. So I'm going to use green. All right. So part 2 alone, notice I'm just talking about that middle section. So if I talk about the middle section alone, do you see part 2 starts, that initial position is at 5, right? What do we think? And that final position is 9 right here, just part 2, like this part to there. Okay? Now, you need to also then sort of see those happen at very specific times now. It's not 0 to 9 anymore, right? Because it was at position 5, like 0, 1, 2, 3 seconds into the motion, right? So that initial position now is associated with time equals 3. And that final position is now at 0, 1, 2, 3, 4, 5, 6. So in other words, that initial position and that final position are associated with certain very specific times that they occurred. And so this displacement, which is clearly 4, represents the displacement between 3 and 6 seconds. Right? And then so I'm going to add those numbers onto my position graph. For example, at the beginning of the second part, your position was at 5. At the end of the second part, your position was at 9. And that happened at time equals 3 to 6, right there. So for this time period right here, the initial position might be 5 and 9, but then those times happen between 3 and 6. All right. So then how about this? Let me show you how this might then look for an overall velocity graph. So show you how these images might connect to a velocity graph. So I'm going to draw a velocity graph that might represent this whole thing and where the numbers in the velocity graph might relate to these things. All right, so let me draw a velocity graph right here. I'll draw that in blue. So here's going to be a velocity graph right here. Okay, I'm going to do like positive speeding up, positive constant speed, positive slowing down, right? I can sort of see these times. Part 1 clearly was from 0 to 3 seconds, right? 0, 1, 2, 3. Part 2 was from 3 to 6 seconds. And then finally came to a stop after 9 seconds there. Okay. Now, let me show you how the displacement comes into play right here. See, the displacement for the first part was 3 meters. That would mean this area right here was 3 meters. See, the displacement in the second part was 5 to 9, which is 4 meters. So I mean this area between the 3 and 6 times is going to be 4. See how the displacement from the 6 to 9 time was 9 to 12, so it's another 3 meters in this last part. That means this area here is 3. And this is how these 3 images kind of link together. Okay. So then let me give an example then of kind of the questions I was asking yesterday and how it all might come together. Here, I need to erase a bunch of stuff here. So, okay, so let's see this question right here. Okay, so, all right, see that graph right there? That's the same graph I just drew. Velocity graph. So maybe you're given that. Let's just pretend you already calculated these areas. That first triangle is 3, the second rectangle is 4, the last triangle is 3. Okay. See these 3 questions right here? Let's make sure you understand what I'm asking. All right. Notice I'm asking, where is it at 6? Where is it at 6? Where is it at 6? Those are all the same questions. They're all going to have the same answer. Let's make sure you understand. I'm asking for each one, what is the position at a specific time? You see that? What is the position at a specific time? What is the position at a specific time, right? Notice they're all the same questions. They're all going to have the same answer. What's different is that what other piece of information I gave you. Notice in the first question, I gave you another position at another specific time. It was that position at that time. So what this is considered not to be an initial position because it's at the time at the very beginning, 0. And then I'm asking now for a final position at a later time, at 6 seconds. So is it pretty clear? At that time, you have an initial position, and I'm trying to find the position at a later time. So this is now indicating that I need to use the 0 to 6 displacement from here to there. So that displacement then is going to be the first 2 sections, which is 7. So when I think initial position is 2, displacement from the graph says 7, so then my final position, if I start at 2, my displacement 7, my final position is definitely going to be 9. Right? But notice the second question, it's sort of the same final question, but notice what I gave you is different. So I gave you a position at a different time. So notice that initial position is at a different time, at 3 seconds. I'm still finding the position at a later time, 6, but now since I gave you the position at 3 seconds, you only care about the displacement between 3 and 6, not 0 and 6. Because my initial position was at 3 seconds. So the time period that I care about the displacement is the time between 3 and 6. So I'm now only caring about the middle block of 4. So if I start at 5, displace 4, I'm going to end up at 9. So it's sort of the same question. I just gave you different starting information. Right? Take a look at that last one. See the last one? See how I'm asking for a position at a specific time? And do you see the other position I gave you at some other time, right? Do you guys see the time and the position I gave you? See that 12? There's a little bit of a twist. Is that a start position or a final position that I gave you?
Final.
How do you know that this 12 is a final position? It's not just that.
Because the time's after the one it's asking you for.
Right, do you see, I'm asking about the position at time 6. And if I gave you the position at time 9, that's after that position, right? So that clearly indicates that this is actually a final position, not an initial position. Just because it's at a later time, right? Which means that this position I'm asking you for is actually the initial position. For what time period then do I need the displacement? Between 6 and 9. Right? So the time period I care about is between 6 and 9. The displacement clearly is 3. So if my final position is 12 and my displacement was 3 to get there, you can sort of see my initial position had to be 9. To accommodate that displacement and final position, right? So there's 3 different ways of getting the same answer. Right? 3 different ways I could have asked that question. And they're all going to get the same answer. So let me relate this to some of the questions I asked yesterday. So let me come right to here. So see this question right here. See the question in blue? Do you see that I have given you one position at one very specific time? Right? Do you guys see that? And I'm asking you for another position at another specific time, right? So do you see that every position has some sort of time associated with it when it happens, right? Okay, so see that first number? What was the first position? 4, right? And at what time did that occur?
3.
3. Can you guys see that? And then do you see I'm asking for a later position? At what time? 7. So first off, is that 4? Is that an initial position or a final position? Initial position. What time period do I need to look for then? Between 3 and 7. So I need the displacement between 3 and 7, right? And then between my displacement, which is that area that I shaded in, and the initial position, which is 4, I can find the final position, right? Let's try another question that I didn't ask you yesterday. Let's see if you guys can kind of pick your way through it. Okay. See this question right here. Let's try that. Do you guys see if this is in one time that I gave you? Do you notice I'm asking for the position at a different time? Okay. Be very clear. That position I gave you, which is 90, right? Is that a final position or initial position? Some people are saying final. How did you know that was a final position I gave you? Oh, because that's at the later time, right? So you need to think of this as x as final position, right? At t equals 8. And then clearly you need the initial position at t equals 5, right? So then what does that mean to you? What displacement do you need to find the times between? 5 and 8. Can you guys see that now? So that means you know, oh, I need to find out what happened displacement-wise between 5 and 8, which is then that section right there and that area right there. Why don't you go ahead and find that? Okay. Can you find that displacement? I mean, it's pretty easy. It's a rectangle, right? What'd you guys get for displacement? 120? Everybody agree with that? 120? Okay. So now we're right there. You know the final position is what again? What your final position is what? Your displacement is 120, which you got from the graph, right? So now I'm asking, of course, about what the initial position must have been. Put those two together. Where did you have to have started? Negative 30 is the correct answer. Because that's the only way you have to start at negative 30, travel 4120 to end at 90. Right? So do you kind of see there's like you don't want to like memorize the steps. There's like a logic behind everything you're doing. You're kind of putting together information, all right?